All right, today we're going to talk about Chile because they are doing something really groundbreaking with a new national standard. It's set to completely change how they build, well, everything. We're talking hospitals, schools, roads, you name it. So let's jump right in and unpack what this is all about. You know the story, right? We've all seen it. That big new public project, maybe a subway line or a hospital expansion, it's always delayed and it always seems to go way over budget. It almost feels like that's just the way things are. But what if it doesn't have to be? That is the exact problem Chile is trying to solve with this standard. And look, this isn't some small niche issue. It's a massive deal. Construction makes up over 7% of Chile's entire GDP. So when that huge slice of the economy is inefficient, it's not just a problem for builders. It's a major drag on the whole country's finances. It really does affect everybody. So here's the crazy part. Even though it's this massive economic engine, the construction industry has been kind of stuck in a rut. For years, it's had this really serious productivity problem. There's this huge gap between what it could be doing and what it's actually doing. Okay, so in this first section, let's really break this down. What's the deal with this construction conundrum? And where are all these inefficiencies actually coming from? So, to really get a sense of how big this issue is, a McKinsey study put a number on it. And it's pretty staggering. It found that Chile's construction sector is only 48% as productive as the US. Let that sink in for a second. That's less than half. A gap like that is a massive red flag. It basically screams that something fundamental has to change. And listen, this is not about people not working hard enough. It's not that at all. The problem is that the whole system is kind of broken. You've got architects over here, engineers over there, and construction crews on site. And they're all working in their own little bubbles. They're not communicating well. Different teams have different ways of doing things. And there's just not enough modern data-driven management. It's basically organized chaos. So, if the system's broken, how do you fix it? Well, you need a solution that can fix the whole system. And that is where this thing called BIM comes into the picture. It's both a technology and a whole new way of working. BIM. It stands for Building Information Modeling. Now, you might hear that and think, oh, so it's a 3D blueprint. But it is so much more than that. The best way to think about it is as a digital twin, a perfect virtual copy of the actual building. And every single piece in that model, I mean every light switch, every pipe, every beam, isn't just a shape. It is packed with data all living in one shared intelligence base. And what this does is it creates a night and day difference in how people work. On one hand, you have the old way, a total mess of separate files, huge communication gaps, and those awful, expensive surprises that always pop up on the job site. Then you have the BIM way. One central model, one single source of truth, and a workflow where everyone is collaborating. You can solve problems on the computer, virtually, before you've even broken ground. Okay, but here's the catch. Just having a super powerful tool like BIM isn't enough. If everyone uses it in their own different way, you've just traded physical chaos for digital chaos. You need rules. You need everyone on the same page. You need a national playbook. And that playbook? That's exactly what the Standard BIM Pro Proyectos Públicos is. It's the government's official game plan, created by an agency called Plan BIM. It's designed to make sure that every single public project uses BIM the same way, in a consistent, structured, and totally predictable manner. The whole point of this, in their own words, is to create a shared language. And that's a powerful idea. It means it doesn't matter if you're a giant corporation or a small local contractor. It doesn't matter if you're building a hospital for one ministry or a bridge for another. Everyone, and I mean everyone, is speaking the exact same BIM language. So how does this playbook actually work in the real world, on a real project? Well, when you boil it all down, it's actually pretty brilliant in its simplicity. It's all about creating a very clear, structured conversation. And this is what's so smart about the whole system. It takes all this complex technical stuff and simplifies it into a formal, two-way dialogue. It's just a conversation between the government agency that wants the project and the private companies that are going to build it. The conversation kicks off with something called an SDI. You can think of this as the government's ask. It's a document where the government clearly says, here's what we want to build, and here is exactly why and for what we are going to use BIM on this project. It's not just we want a model, it's we want a model to do these specific things. Then, the ball's in the contractor's court. They respond with what's called a PB, and this is the contractor's plan. It's their detailed answer, their strategy, explaining precisely how they're going to use their team, their technology, and their process to deliver on every single requirement the government asked for in that SDI. So really, it all comes down to this simple two-step dance. The government makes a clear, specific ask. The contractors provide a detailed, strategic plan. That's it. And that simple, elegant interaction makes sure everybody is 100% aligned before a single shovel hits the ground. Okay, so we've got the playbook and we've got the dialogue. But so what? What does this actually let us do? How does this all translate into better buildings and, a better future? Well, remember, the standard isn't about making a pretty 3D model. It's about putting that digital twin to work. And it defines 25 specific BIM uses. These are basically powerful, practical things you can do with the model to get real, tangible value out of it. Let's look at a couple of examples. One of the big ones is cost estimation. Instead of just a rough guess from some 2D drawings, you can literally ask the model, how much concrete do we need? How many windows? And it will tell you the exact amount. This gives you a super accurate cost estimate right from the start, which is just crucial for preventing those budget blowouts. Or here's another one that's a total game changer, 3D coordination, sometimes called clash detection. This is huge. The software automatically scans the model to find problems. Like, hey, this giant air duct is on a collision course with that main support beam. Finding that on a computer screen costs basically nothing to fix. Finding it on the construction site? That's a nightmare of delays and costs. And this stuff gets really forward-thinking. Take energy analysis. You can run simulations on the digital twin to see how the building will actually perform. How much will it cost to heat and cool? This allows you to optimize the design for energy efficiency, leading to more sustainable buildings that cost less for taxpayers to run for decades. So when you put it all together, why does this technical standard really matter to you? Well, it's pretty simple. It means less public money is wasted on mistakes and inefficiency. It means the schools, hospitals, and roads your community relies on are built faster and to a higher quality. It brings a lot more transparency to public projects, and ultimately, it helps build a more productive and sustainable Chile for everyone. But this all points to an even bigger idea. It leaves us with this final, really fascinating thought. This is about more than just one project at a time. It's about building a collective digital memory for our infrastructure. So what if every city wasn't just built with concrete and steel, but with a shared digital blueprint for the future?